All right, class, we're looking at imaginary numbers today. Imaginary numbers. What are imaginary numbers? Well, imaginary numbers is like if you have a square root of 25, this is 5 because 5 times 5 is 25. Okay? What if you have the square root of 16? Well, that's 4 because 4 times 4 is 16. All right, here's where imaginary numbers come in. What about the square root of -9? What number times itself is -9? Well, it can't be -3 because -3 times -3 is +9. This is an imaginary number. So what we do here is this negative comes out as an I. And then the square root of 9 is 3. So this is 3i is what this is. Okay, so just a little bit of review on this stuff. All right, let's look at this first one. We got a few of these problems here I already wrote down that we're going to work on. The square root of -432. Well, first off, this negative comes out and gives us an I. Okay. All right, then I want to see how this breaks down and see what comes out of it. All right, so what I'm going to do is I'm going to just break this down. I'm going to start with 2. 432 divided by 2 is 216. Circle my 2 because it won't break down anymore. 216 divided by 2 is going to be 108. Circle my 2. 108 divided by 2, 54. Circle my 2. 54, you just keep dividing by 2. That way all your 2's will be together. 54 divided by 2 is 27. 27, now it don't divide by 2, so I'm going to go to 3 and try it. So 27 divided by 3, it is 9. And then 9 divided by 3 is 3, and there you go. That won't break down, so there you go. There's 432 broke down in primes. Okay? Now, when you break them down in primes, you look at your primes, and you look for pairs. And I can see right here, these two pair up. That's going to send a 2 out of the radical. These two right here are going to pair up. That's going to send another 2 out of the radical. These two 3's, they pair up. That's going to send a 3 out of the radical. But this 3 right here does not have a partner to pair up with. So he's stuck in the radical. So that means I got 2 times 2 times 3, which is 12. I got 12 coming out of the radical. I've got this 3 stuck in the radical. And then don't forget my I right there. My I goes between them. And that's what that simplifies to. 12i radical 3. Okay, there's a couple more. There's one right here. Now this one's not as big, 44, but as soon as I see that negative, it sends out an I. Okay, we don't want to forget about him. 44 divided by 2 is 22. 22 divided by 2 is 11. And 11 don't break down. All right, so on this one, all I have is this one pair of 2's. That's going to send a 2 out. This 11 doesn't have a partner to come out with, so he's stuck in the radical. So I've got a 2i radical 11. Okay, 2i and a radical 11. One more like that. Negative radical 120. So radical negative 120, sorry, that sends out an I. So I break down my 120, 2 times 60, 2 times 30. 30 is 2 times 15, and then we won't do 2 no more. 15 is 3 times 5, and there you go. Those are, right, there's my primes. What do I have pairs of? Right here, I got a pair of 2's. That's going to send out a 2. What else do I have a pair of? That's it. This 2 is stuck because he has no partner. This 3 is stuck. He has no partner. This 5 is stuck. He has no partner. So all 3 of those are stuck in the radical. So I've got this 2 coming out. I've got my I out. And in the radical, I've got 2 times 3 times 5, which is 30. There you go. There's my answer. All right, so that's how you simplify radicals that are imaginary with negative numbers in the radical. Okay. Now, what about something like this one here? We've got some radicals multiplied together. Well, since these are radicals, they're all in radicals, I can put all them in one big radical. like that. Okay, and then I just multiply them together. So when I multiply them together, what do I get? Well, 6 times 12 is 72, times 5 is, what is that, 360? And then 3 negatives would be negative. Okay? Negative 6 times negative 12 is positive 72. And then positive 72 times negative 5 is negative 360. Usually what I do is I just multiply them, and then however many negatives are, if there's an odd number of them, it's negative. If there's an even number of them, it's positive. All right, so now I've got to break down this radical just like I did the other problem. So the negative comes out as an I. I break down my 360, so that's going to be 2 times 180. 180 is 2 times 90. 90 is 2 times 45. And I can't do 2's anymore, so I'm done with the 2's. Now, 45 is 3 times 15. 15 is 3 times 5, and then 5 doesn't break down, so it's stuck. Okay. Now what do I have pairs of? Well, there's a pair of 2's. That's going to send a 2 out of the radical. This 2's stuck. He has no partner. There's a pair of 3's. That sends a 3 out of the radical. This 5 is stuck. He has no partner. So he can't come out. He's stuck in the radical. These two guys are stuck. These come out. So 2 times 3 would be 6 coming out. So I've got a 6, I've got the I, and then my radical, I got 2 times 5, which is 10. There you go. All right. Now I have these things right here. Sometimes, like I just mentioned a while ago, when you have negatives, you count how many negatives are, and if it's odd, it's going to be negative. If there's an even number, it's positive. Same thing goes like if you have an exponent on I, okay. One thing you have to remember now is on I to the 1 power is I. I squared is negative 1. I to the 3rd power is negative I. I to the 4th power is positive 1. Right, these are the 4 main units here. And then I to the 5th power, it reverts back to this, and it starts the whole thing over again. Okay, well, I to the 5th, if you take 5 and you divide by 4, you get 1.25. Okay, now right here, I got 0.25. I asked myself, how many quarters would that be in money? That's 25 cents. That's 1 quarter. So see, I to the 5th is the same thing as I to the 1. So that's all I do on these right here. When I have these exponents that are rather big like this, I just divide by 4 and see how many quarters that would be, like I just did on this. It's like 50. Okay, here, let's take my calculator here. 50 divided by 4 is 12.5. So 50 divided by 4 is 12.5. All right, well, there you go. That's not dollars and cents. They're add the 0 on, and that's 50 cents. How many quarters is that? Well, it's 2. So this is the same thing as I squared. And I squared is negative 1. There's my answer there, negative 1. Now, you need to remember this right here. You need to remember this little table right here. So like right here, 41, I to the 41. Okay, let's take my calculator here. 41 divided by 4, 10.25. All right, so I do 41 divided by 4, 10.25. Now I ask myself how many quarters that is. 0.25, 25 cents, that's 1 quarter. So this is the same thing as I to the 1, which for my table is just I. What about I to 36? Okay. 36 divided by 4. It's just 9. 36 divided by 4 is 9, which means we have no change here, which means we have 4 quarters, which made another $1. This is I to the 4th, which is 1. I to the 4th is 1. Okay. Again, when I do 36 divided by 4, it's 9 with no quarters, which means I've had 4 quarters and it made $1. Okay. And then I got 287. I to the 287. So I do 287 divided by 4. All right, here's my calculator. 287 divided by 4. 71.75. Which is 3 quarters. 75 cents is 3 quarters. So this is the same thing as I to the 3 which is negative I. Okay, so that's how you do those. All right, then we're going to get to some more little operations here. All right, so we've got to multiply these. All right, so 8 times negative 7 times 4. You just multiply them up. Here, get the calculator here. So you just see I'm punching in 8 times negative 7 times 4. That comes up negative 224. All right, then I've got I times I times I. That's I to the third. Okay. Now, I to the third, that's a negative I. So this is negative 224 and a negative I. Oops. Negative I. From this table right here, see I to the third is negative I. So this is negative I. So I got negative times negative. See, there's two negatives, which makes it a positive. So it's going to be positive 224I. There you go. That's what it is. Okay. Let's go to this next one here. All right, now this one here we got to the third power, so we want to have to do that. So 2 to the third power. See, this is 2 to the third power times I to the third power, which is 2 to the third power is 8. I to the third power. Times, now right here, I got to do this. So this means I have I squared, and I've got radical 5 squared. All right, well, let's put my numbers first. See, radical 5 squared, the square cancels the square root, so that's just 5. And that's going to be I squared. Okay. And now I can multiply them now since the parentheses are gone, the exponents out. See, these exponents outside the parentheses, we got to get rid of them. Now they're gone, so I got 8 times 5, which is 40. And I've got I to the 5th. Okay, I to the third times I to the 5th is I to the third times I squared is I to the 5th. And so now the same thing, you do 5 divided by 4, which is 1.25. How many quarters is that? Well, it's 1. So this is the same thing as 40I to the 1, which is just 40I. I to the 1 is just I. So there's my answer right there. Okay, now we have some solving we're doing. We're going to solve this expression, this equation right here. So I'm going to divide both sides by negative 3, see? To make this cancel off, x squared equals, that's going to be negative 60. Okay, so now I square root both sides to cancel off the square here. Okay, so x is going to equal. Now here's the thing. When you square root both sides, let's go to one. Let's take this off a minute. When you square root both sides, let's do an easy one. X squared equals 9. Okay? X squared equals 9. When I square root both sides, the square cancels the square root. X equals the square root of 9 is 3. But when I square root both sides on the equation, it could be positive or negative. So this is plus or minus 3. Okay, now if you go back to the original problem, x squared equals 9. This is the original problem right here. If I put 3 in, 3 squared is 9. But if I put negative 3 in, negative 3 squared is also 9. So both answers are good. So this is the thing you have when you have square roots. When you do the square root on both sides, this is which is called the square root property. You have to have positive or negative as your solution. All right, so on this one then, when I'm doing this, the square root on both sides, it's going to be plus or minus the square root of negative 60. Okay, it's going to be plus or minus because I did the square root on both sides. Now I've got a radical negative 60. I got to do the same thing we've been doing. So this is going to send out an I. And then I got to break down my 60. So 60 divided by 2 is 30. Circle the 2. 30 divided by 2 is 15. Circle the 2. 15. I can't do 2 anymore, so I go to 3. That's 3 times 5. It's a 3. They won't break down. What do I have a pair of? There's a pair of 2s. That's going to send out a 2. Stuck, because neither one of them have partners. 3 doesn't have a partner to pull out with. 5 does not have a partner to pull out with. So the 2 comes out. So here we go. X equals, the 2 comes out. It's going to be plus or minus 2i, and then 3 times 5 is stuck in the radical. 15. There you go. There's my answer. Oh, it was not on the screen. Sorry. So the 2 comes out, it's plus or minus. I've got an I, and then 3 times 5 is stuck in the radical, so it's a 15 in the radical. Okay, let's go to this next one here. We're solving this, so I'm going to subtract 15 on both sides. That makes this go away, so negative x squared equals, what is this, 17? Okay. Now that's a negative x squared, which means I would divide by negative 1 to make the negatives cancel off. So x squared equals negative 17. And I've got the same thing we just had a minute ago. And we'll square root both sides. So square root cancels the square, have x equals. When I square it here, remember now, it's going to have to be plus or minus. Okay, I got to break down my 17. Well, that won't break down. So, I left my negative out there. Yeah, there's a negative in there. 17 won't break down, but that sends out an I, so it's going to be plus or minus I, radical 17. And there you go. That's all we can do. This one does not break down. Okay. Now this last one. We want to solve this. Here's my x right now. That should be squared. Left the square off when I wrote it down earlier. We'll solve this. So here's my x. Well, there's this plus and minus number, so I'm going to have to add 12 to both sides to make this go out. So I have negative 4/3 x squared equals, and this is going to be, was it 208? Okay. All right, so now I got to divide both sides by negative 4/3. It makes this cancel, so x squared equals, all right, now here's one. I'm dividing by a fraction. Keep, flip, change. Sorry, I did it backward. Keep, change, flip. Keep, change, flip. I got KFC on the brain, not KCF. I got KFC on my brain. I'm hungry. But it's KCF. Keep, change, flip. So I keep the 208. I change from divide to multiply. And then I flip this negative 4/3 to negative 3/4. Okay. So I put this over 1. And then I can multiply this out. Now, I can cross cancel, or you can just punch this in the calculator. I mean, see, look at how it works out. If I do 208 and I times it by, in parentheses, negative 3/4, I get negative 156. All right, if I do this right here, 208, and I divide by negative 4/3, in parentheses, negative 4/3, see, it's still negative 156. Okay. All right, so x squared equals negative 156. Now I square root both sides, just like we've been doing. So the square root cancels the square, so x equals the square root of this. Now remember, it's going to be plus or minus. And this is going to send out an I. Okay, now I got to break down to 156. So let's try this. Divide by 2 would be 78. Circle my 2. Divide by 2 would be 39. 2 won't do that, but 3 will. 3 and 13. And I think that's it. 13 won't break down. So it looks like I got a pair of 2s. That's going to send a 2 out. I got an I out, so this is going to be my answer here. It's going to be plus or minus 2i, and then my radical, 3 times 13, 39. And there you go. All right, so it's a little bit about imaginary numbers today. If you have any questions or comments, just please let me know, okay? And I hope you have a good rest of the day.